Good afternoon, everybody. Welcome to my class on stochastic process from any part of the world and from within the class. In today's class, we will continue from where we stopped previously and we will progress as far as we can. Okay? So let's resume from where we stopped in the last class. I said in the last class that a random walk can also be described as what? A Markov chain. Then the Markov chain xn greater than or equal to 0 can be seen as a random walk, in one dimension. If this condition I'm about to write holds. So if the probability Pij assumes P for j equals I plus 1 or Q for j equals I minus 1 or 0 otherwise. Where I and j can take values 0 plus or minus 1 plus or minus 2 and so on. What are I and j representing? May I ask? I and j will be representing states. Do you understand me? And in a one-dimensional random walk, we say we are operating in a linear system. Okay? So that more or less we are operating on the real line, and this is a state. This will constitute a state. Do you understand me? And 1, that is plus 1, plus 2, plus 3, and so on to the positive side of 0 will constitute different states, such that a particle can move in that direction, that is one step at a time, a unit step at a time in the positive direction, or you could do what? Move backwards, unit steps, but in the negative direction. Do you understand me? Now, take a look at this. Take a look at this, that the particle moves. If you call, what do you call it? If you call the state you are currently in J, that is the state you are moving to, then if you are moving, if you don't move, then that is if you start your movement is supposed to start from J equals 0. If you don't move, it means your I will be equal to your J. I hope you know that. But your new destination J will be equal to I plus 1 if you are moving in the positive direction and you are taking what? Unit steps. Remember, our assumption is that we are talking about a simple random walk, and in a simple random walk, you move one step at a time. Is it clear? One unit step at a time. So if you move in the reverse direction, then the new state you will get to J will be equal to what? I minus 1. Okay? And in that way, if you consider this to be the case, then it will mean that you might just be looking at what? A Markov chain. In that sense, the Markov chain you are discussing will now be a Markov chain, what do you call it, depicting an instance of a random walk, or a random walk depicting an instance of what? A Markov chain. I hope you understand what I'm saying. So please, that was just what we were trying to describe, that a Markov chain can be considered to be an instance of a random walk or otherwise. So please, let's now, where I, J are states in that manner, and you have P plus Q, of course, will give you what? 1, because they are complementary, right? 0 less than P less than what? 1. I would love to put mine that way, because it could be happen both ways. Now, that being said, let us now go into what the focus for today's class is. I want us to consider the probability distribution, of xn. the probability distribution of xn. Okay? So xn happens to be one random variable in a stochastic process. Please write, we derive the probability distribution of the random variable xn being the value of the process or x coordinate of the particle at time n greater than or equal to 1. So that is just to tell you that nobody should take xn as a stochastic process. So please take note of that. Then define, please, I'll put this statement as, to do this, we shall define P xn to be equal to k. That is the probability that this random variable in the stochastic process assumes the value what? K. To be equal to the probability of moving from a state 0 to n, okay? And state 0 to that k of n, okay? And n greater than or equal to 1. So we shall define that to be the probability that the particle starting at the origin is at the point, k on the nth step. Now, there is need to bring up that notation because the notation is needed in trying to establish the probability distribution of xn. There is need to bring up notations that are flexible. Do you understand me? A notation we would use in establishing that fact. Now, please take note. Let's go back to the diagram again. It is very easy to put this diagram again and again because the diagram makes what you want to do very, very clear. Is it clear? Now, look at the diagram again. Of course, we are dealing with a simple random walk, so we are in a one-dimensional system. Okay? Now, looking at the diagram, this is, let's call this state 1, state 2, and ellipsis state k. What we have just done by saying that P xn equals k, should this, that is, if you want to describe the probability that xn, the random variable, assumes a value k after the nth step. So what we are saying is this: if it takes n steps to get to k, then we are saying that that probability should be represented as what? The probability of taking n steps to get to k. That's the state k should be denoted as P0k. Is it clear? So the probability is not the probability of moving from 0 to 1. Take note, your k can be 1, it can be 2, it can be any value. So it is a dummy variable. Okay? So that is what we are trying to describe, and we need that notation in trying to prove what? The probability of what? The probability distribution, to develop the probability distribution of what? Xn. More or less, the probability distribution of Xn, please take note, is not all of us trying to discover a new distribution. We want to know among the established distributions in statistics, whether quadrant, whether what do you call it, uniform, whether normal, or any other type, hypergeometric, geometric, as the case may be. We want to know for a simple random walk, the random variables in a simple random walk, what probability distribution do they follow? Do they follow a quadrant distribution? Do they follow a hypergeometric distribution? Do they follow a Bernoulli or a binomial distribution? What distribution do they what? Follow? Do you understand me? That is what we are trying to establish here. More or less, we are trying to answer the question. Now that we know that xn is a random variable in the stochastic process, precisely a simple random walk. Take note, a simple random walk is a stochastic process. The question we are trying to answer under the subheading is what distribution out of the known distributions we are already dealing with in statistics will this xn follow? I hope you know. So you know that random variables follow distributions. So which one does xn follow? That's the question we are trying to answer. So we are trying to, in that development, make it easy as possible for us to use what? Notations that are flexible. Is it clear? So let's proceed. Now, recall that the number of movements to the right, recall that the number of movements to the right, that is positive jumps. Recall that the number of movements to the right, that is positive jumps plus 1. Rather than use the word recall, please let's use the word let. Okay? So I'm going to say here, please correct that. Let the number of movements to the right, that is positive jump. You remember we called every movement a jump, right? So let the number of movements to the right, that is positive jumps, plus 1, be denoted by n plus. Okay? And let the number of movements to the left, that is negative jumps. That is negative jumps minus 1 let me put this ahead. Be denoted by n minus. Okay? Where n plus and n minus are random variables. Let me ask a question. Why would the number of positive or negative jumps be random variables? If you go by what a random variable is defined to be, a random variable is defined to be a real valued function defined over a probability space, right? And we said in a simple random walk, a particle moves in unit steps to the positive or to what? The negative with assigned probability values, right? Now, if you are now saying that n plus and n minus should represent the number of what? Jumps to the right or to the left. The number of jumps, if you want to consider the number of jumps to the right, at some point in time, the number of jumps denoted by n plus could assume 1, it could assume 2, it could assume 3, in accordance with certain assigned probability values. You know so? So that makes it by definition a random variable because it assumes value with assigned what? Probabilities. So n plus and n minus are by definition random variables. So you are only being reminded. Is it clear? I hope I'm talking to people.
Yes, sir.
Now, let's proceed. So the position of the particle at the nth step, therefore, must be xn equals nn plus minus nn minus, where n is equal to nn plus nn minus. Now, so the position of the particle at the nth step therefore must be xn equals nn plus minus nn minus. This is more or less like what you would call in physics the resultant vector. You understand me? In vectors, you must have been told that if you move from A to B, if there's a vector from A to B, and you move from what? A to C, the triangular law of vector, you move from A to C, the resultant vector will be what? A to C, right? In which case you have A to B plus B to what? C, giving you what? A to C. Is it clear? This xn equals nn plus minus nn minus is your resultant vector. This n here represents the total number of steps. Please put the camera here. Now, if I look at it this way, so this is 0, this is 1, this is 2, and this is 3. So look at minus 1, minus 2, minus 3. Now, let's assume that you start your movement at 0. What I was trying to explain here. You start your movement at 0, move to 2. How many steps? 2 steps. Okay? Now, you now move backwards. That is your number of positive steps. It means your xn plus, in this case, is what? Is 2. Now, let's assume that your task was to get to xn at minus 1. So, I will move once, 2, and then what? 3. Xn minus is what? Is 3. You see it? N is the total number of steps you move. How many? 5. Your xn, sorry, this was supposed to be nn. You would have corrected me. Okay, so look at it. I want you to make it vivid. Is it clear, everybody? I don't want anybody memorizing these equations. These equations are what you know. Do you understand me? If you understand vividly what is going on, we are in a simple linear random walk. So if you understand vividly what is going on, you won't need to be cracking your head how this explanation, these equations are. Look at it this way. We have said this one should represent the number of positive steps. That is forward steps, right? This one, the number of backward steps, if you put it that way. Now, I took, my destination is minus 1. I wake up in the morning, I want to move backward. But for me to go backward 1 step, I have to go forward 3 steps. I now move 1, 2, 3 forward steps. N will be what? I move 2 forward steps, 2 forward steps, right? Then I'm now going backward to get to my destination, minus 1. I am now moving 3 steps backward. This N here represents your number of steps, whether you move forward or you move backward. How many steps did you move all together? It will be the number of forward steps plus the number of what? Backward steps. I don't want you to see it as negative steps, backward steps. So add your number of forward steps to your number of backward steps, it will give you a total of what? N, which is your number of steps. Now, but when it comes to xn, xn is now what is comparable with what you call the resultant vector. What was xn now represents your net movement. Do you understand me? Which in this case now, if I ask you what is xn, xn will be the number of forward steps minus the what? The number of backward steps. Is it clear? So in this sense, it will be 2 minus what? 3. That is why at the end of the day, you will discover that you are at minus 1. Do you understand me now? If you take xn, which is nn plus in this particular instance minus nn minus, you will discover that you are what? You are minus 1 because this was 2 minus 3. That is how you know that the state you will land after making these movements will be what? The state minus 1, which is this. Do you see it now? I hope it's clear. Yes, sir. Good. Let's proceed. Please write. Adding, let's call this, guys, let's call this equation 1, let's call this equation 2 because of the next formulation. Okay? So adding equations 1 and 2. Let's now add equations 1 and 2. If you add equations 1 and 2, what would you have? What would you have? If I add equations 1 and 2, I hope you know that this and this will add to give what? 2nn plus, right? And this, it will now be, this would eliminate. Minus nn minus plus nn minus will be 0. Then you have what? Here will be equal to n plus xn. Is that also? So call this, I don't think we should even call it equation 3 until we simplify it. I don't want to have more equations than that. So you have this. So adding equation 1 and 2 gives, let's call it equation 3. There's no harm in that. Now, making nn plus the subject, making nn plus the subject of formula gives, we'll end up having, let's go over here. We'll end up having nn plus equals half n plus what? Xn. Call this equation 4. Okay? Remember, guys, our focus still remains getting the probability distribution of what? Of Xn. Is it clear? Yes. So at this moment in time, we yet do not know if the probability distribution of Xn is a Poisson distribution, a binomial distribution, a Bernoulli distribution, a normal distribution. You know that's our task, right? So let's now see. Thus, we have that Xn equals k if and only if nn plus is half n plus what? What is Xn? K. Do you see it? So if for Xn to be equal to k, then it means the number of positive steps you take must be half the sum of what? N, the total number of steps, plus what? K. Do you see it? Now look at it this way. If I had given you, please let's come back to reality. Look at it again. 1, 2, 3, 4. Minus 1, minus 2, minus 3. Guys, please look up. Pick, okay, sorry, thank you very much. 0, 1, 2, 3, and 4. Pick your k at random, whether to the positive or the negative. Pick your k. Let's assume that k is equal. Let's pick 4 as our k. Pick k equals 4. Then let's assume, you know, we want to get to k. Now assume this way that we started with moving 2 steps backward. In which case you have nn minus to be what? Nn minus is what? 2, right? You move 2 steps backward, nn minus is 2, but you want to get to k. For you to get to k, which is 4, you have to first of all go back. It's just like having a relative dying this morning, and you are supposed to make progressive movements to family relatives that are within your environment. But you are told that no, that's not the tradition. No, the tradition requires that before you yet let anybody hear about that death, you have to go back to the village. You understand me? If not, you would have committed an abomination. So you now decided to go to the village first, 2 steps backward, before going what? Forward, to announce to every other person. So you went back to the village twice, 2 steps backwards, and then you now started your forward movement after telling them. How many? 6. So n plus is what? 6. What is n? 8. You see it? Now, if you are to arrive at k equals 4, what we have just shown is telling you that n plus, which is 6, must be equal to half of n. What is your n? 8 plus your k. What's your k? 4. Do you see that it will give you 6? That's what that stuff is telling you. I hope you understand me now. So if you don't want to, let's assume I didn't tell you what n plus is. I only gave you the number of steps you took all together plus what and your k. You can still determine your what? Your number of positive movements towards k. Is it clear? So I hope we can proceed. Quickly, let us continue. It can be noticed that n plus is a binomial distribution. It's a binomial random variable, sorry. It's a binomial random variable. We have stated earlier on that n plus is a random variable. But now clearly you can see it is a binomial random variable. Why is it a binomial random variable? Why? Why are you confident that n plus is a binomial random variable? What's a binomial random variable, please? At every instance, what is called a binomial random variable has two possible values. Do you understand me? To which you can call success or failure, and to which you can assign a probability of success or what? Failure. Is it clear? If you examine this random variable n plus with that that notion, you will come to realize that it depicts that scenario of being a binomial random variable. Because at every instance, there are two possibilities for n plus. Do you get me? There are always two possibilities for n plus. So it is a binomial random variable with parameters n and p. This is because each jump qualifies for a Bernoulli trial. You see it? Each jump qualifies for what? A Bernoulli trial. The particle either moves to the right with probability P, or to the left with probability Q. And the particle also moves n steps independently. Also, 2n plus is necessarily an even number. Xn must be an even number if n is even, and let me put a full stop here. Also, 2n plus nn plus is equal to n plus xn is necessarily what? An even number. Put a semicolon here to represent and. And xn must be an even number if n is what? Even. You get me? While xn must be an odd number, if n is odd. Full stop. Therefore, the probability of xn, that is POKN, becomes POKN equals, now that we know that it is binomial, it becomes what? A binomial distribution. What's a binomial distribution for a random variable x? N combination x, p raised to power what? X, q raised to power n minus x, right? So, and that q is 1 minus p, right? So this one will now be what? N combination. What is our x in this case? What's your x? No? What's your x? Thank you. So we have just said the probability of moving from 0 to k is only possible if nn plus equals this. So it means that the probability of moving from 0 to k in n steps will now be n combination nn plus. You see it? And that nn plus is what? N plus k divided by what? 2. You see it? So p raised to power what your nn plus is, which is what? Half n, that is n plus k all over 2, and your q raised to power 1 minus nn plus. 1 minus nn plus will give you what? Simplified. 1 minus nn plus, which is 1 minus n over 2 minus k over 2. What will it give you? 2 minus n plus k all over 2, right? Good. So you end up having what? N minus k over what? Over 2. Let's see. So if I say 1 minus n minus, you know that one is supposed to be n minus n minus n, not 1 minus. No. This q. So it's supposed to be, that was a mistake for me, not you. I was the one saying 1 instead of n. So that would have been n minus x for a binomial distribution, and the variable here is what? N plus k over 2. So if you simplify that, that will give you what? N minus n over 2 minus k over 2. Is it not so? And that will give you what? This would have given you n over 2 minus k over 2, which is n minus k over 2. Okay? So this is correct. Let's stop there. We'll take the remarks that follow in the next class. Thank you very much. And for those of you watching from any part of the world, thank you for staying tuned.